Welcome to AASHTO Resource Q&A. We're taking time to discuss construction materials testing and inspection with people in the know. From exploring testing problems and solutions to laboratory best practices and quality management, we're covering topics important to you. Now, here's our host, Brian Johnson.
Welcome to AASHTO Resource Q&A. I'm Brian Johnson.
And I'm Kim Swanson.
And today we're going to talk about hot mix gyratory samples 55 and 56 in our series of proficiency sample discussions. And with us again are our guests, John Molesky, Director of the Proficiency Sample Program. Welcome, John.
Hey, Brian. Thanks. Glad to be here again.
And Ryan LeQuay, Laboratory and Testing Manager.
Thanks, Brian.
And congratulations on being the arm cover and hand cover model for the latest version of the 2023 AASHTO standards.
Yeah, if you see a neon green glove, that's me.
That's him. He's famous. And we also have Joe Williams, Senior Quality Analyst. Joe, welcome to the podcast again.
Hi, Brian. Hi, Kim. Thanks a lot.
Let's talk about this round of proficiency samples. John, I'm going to start with you. Can you give us a rundown of how this sample is prepared?
Absolutely, Brian. This is actually probably my geek out moment here. This is my favorite sample that we produce each year. I just think so much work, time, and effort goes into this from our end that I think it's awesome. It's probably the best sample that we prepare each year. I love it. Just the amount of effort, quality, time that goes into it. And usually, almost every year, the results are amazing. The data looks great. We never see any issues with it. It's just a really good, well-designed sample scheme. And I think our group can be really proud of the work that they do on this one. But to kind of go into the prep work of it, a lot, we had a podcast, I think it was a week or two ago, about the Marshall samples and Veeam samples. Very, very similar preparation when it comes to the production side of it. The team prepares the aggregate in size fractions, batches it up into bags. Cans of asphalt are sent as well. All virgin material is completely raw. And we develop a mix design in-house by a lot of work from Ryan and myself. And then the laboratories get that mix design, the batch recipe, prepare it. They prepare one specimen for a butter batch and a rice sample, and then 2 compaction specimens per each side. So they're very similar to the setup and practice for Marshall and Veeam, but this one just always seems to be like the cream of the crop sample for us.
Why is that? And how does this design differ from the Marshall or Veeam?
Oh, I don't think it really differs that much. I think there are, I'm going to say, a few more things that we target. Specifically, I think I mentioned some of this, so we target in the Marshall as well, but VMA and VFA. But there seems to be less variability with it than the Marshall. It seems like with the gyratory, it's just more controlled. I feel like the participants really have a good handle on what they're doing and how things work. And the round just comes out so clean. Like even if your laboratory ends up having a lower rating, it still ends up being pretty good. Just the look of the scatter diagrams, it's just like I said, a great round that seems to work out all the time.
How many people participate in this sample?
So this one's actually grown pretty substantially in the past few years. We have just over 1,000 participants. For a while there, it was stuck in like the 700s and 800s. And then we had a lot of pavement associations and DOTs start to work together to use the program as a means of an assurance program between the two organizations. And at least some of them allow for like simpler dispute resolution when it comes to the testing of their own mix designs that they're making within their state. And that has really bumped up the participation in this program. We saw over a 20% increase in the past probably 2 to 3 years. So that's been awesome. And like I said, the data that we're generating from it and the way that the round looks, it's excellent. It's good stuff.
Now, how does this sample participation differ from others internationally?
We still have somewhere between, I think it's 60 and 80 participants internationally, which is right around the same numbers for Marshall. So there's still a reasonable participation level there. I just think that Marshall is still more readily available. Equipment's a little bit easier to get, just a little bit of an easier way to procure all the things you need to run a Marshall and get a Marshall mix design. Marshall's been around for 70 years probably. I don't know. It's just a ballpark, but it's been around for such a long time. And there's just a great way to get the equipment for it. Whereas Gyratory, it's a little bit harder, a little bit more expensive. But I mean, they're still on pace. We got a lot of international participation with it.
I'm thinking about why statistical analysis might look a little tighter than some of the other samples. And I'm thinking about all of the equipment that is much more carefully measured, much more carefully designed, standardized. The angle is standardized, the effort that goes into just making sure that the molds are the right specification now. Do you think that contributes to this? Because I mean, compared to the kind of wide open process of Marshall compaction, it seems like it would contribute to a more consistent test result across laboratories.
I think the gyratory definitely helps remove some of the human variability. Marshall, there's a little more hands-on interaction, different options of equipment, whereas gyratory, it's all in that machine. The machine's handling the bulk of the work there, and that's a lot easier to control.
So Ryan, I got another question for you. Now that you know that this is John's favorite specimen or favorite sample, which I don't know, did you know that already?
He gets excited about it every year.
It was news to me. I had
Yeah,
no
he
idea
comes
this was
in
his
with a spring
favorite.
in his step, you know.
But now that you know that this is his favorite, does that make you a little more nervous about testing it?
No, we're pretty good across the board. We want to have good, homogeneous, and stable samples throughout, whether it's your favorite or not. There's probably more pressure on the ones that aren't our favorite, because if it's not our favorite, that means we're going to do more work on those ones. So, yeah, no extra pressure there.
All right. Anything interesting in 55 and 56 from the testing perspective compared to previous rounds?
No, not when it came to testing on our end. I mean, like I said, in the Marshall one, this is kind of the first round where I took one of them and Ryan took the other. So this is Ryan's really first go at volumetric mix design, and the numbers were really good. So like I said, did another solid job with the design, and looking at our values compared to the grand average, we nailed it again. We had mostly 4s and 5s, so things seemed to work out pretty well for us on our end.
Now, Joe, let's go over to you with some accreditation questions. What do people need to watch out for related to accreditation on the gyratory samples, other than not submitting results? I'm not going to give you that easy out.
All right. Well, I'll probably, put a plug in there for that at some point. From an accreditation standpoint, this one's one of the smaller samples. As far as line items, there's only a handful of tests in this one. Similar to the Veeam and Marshall samples we talked about in our last one, none of the compaction programs include data for T275 or D1188. That's bulk specific gravity by paraffin or parafilm. So if there would happen to be an accreditation suspension for the regular bulk specific gravity, T166 or D2726, suspension of accreditation for the paraffin or parafilm standards would also take place. The only other kind of thing here is some people might notice that this sample includes line items for T100, which is actually a soils test. And the reason that that one is included in this sample is because R35, which is the standard practice for super pave mix design, requires that the mineral filler, the specific gravity, be determined using T100. When we first started accrediting for that a few years ago, probably in 2015 or so, it was kind of a headache for some of these asphalt labs to be enrolled in a soil proficiency sample program just to test T100. So what we did was, or what John did was, he started adding a small baggie of mineral filler to the samples for the laboratories to perform T100 on, and we actually moved that into the aggregate scope. So hopefully that saved some labs a little bit of money by not having to be enrolled in soil just for that one single test. We do get some questions from labs that are accredited for soils testing that have T100 under there. Do I have to submit data for this test? And the answer is no. The only time you need to submit data for that test is if you have T100 mineral filler under the aggregate scope, which really you should only have if you are accredited for R35 under the asphalt mixture scope. So just those two things there. We haven't yet received our lists of suspensions to review, so not really sure how many, but again, similar to those other compaction ones, usually the T209, D2041 maximum specific gravity, that tends to be the one that we do the most suspensions for out of this one. And actually, with the way that the calculations work with T312, sometimes if there's a suspension for that, you can see a suspension for T312 in the percent maximum specific gravity for the 8 and 100 gyrations, because those things are kind of tied together. But as always, a lot of our suspensions come, at least in some part, from laboratories not submitting data. So make sure with all the PSP programs, get data submitted so you can avoid, or at least try to avoid, suspensions just for that.
Yeah, and I know that some of the laboratories, even though we haven't gotten our list of laboratories that need to be suspended, they reach out as soon as they realize they're going to get suspended or they got their low ratings. Have you had any inquiries from your laboratories yet about that?
I'm not necessarily sure about in this sample, but usually in other samples, we will get those inquiries. And so, yeah, that's a good reminder, is that accreditation suspensions come from low ratings or no data. So the low ratings would be a 0 or a 1 on the same line item for both samples for 2 sample rounds in a row. So it does take actually 4 consecutive samples, not sample rounds, but actual samples, for a suspension to take place. So if you just got a 1 on one sample this round, there's no need to reach out to us, but you do have to take corrective action on any low ratings per a laboratory's quality manual and file those corrective actions and those reports and investigations, because when our assessors come around to your laboratories, they will look for records of that.
Yeah, that's a good point. And the corrective action process starts when you get 2s, even though we don't suspend until you get 0s or 1s. So you want to start making those improvements when you get into that low rating area of 2 and -2. Those are great reminders, Joe. Thanks for that.
So I'm going to touch on a little point here. Joe, you just got done discussing some of the things with the accreditation program and that line item about the mineral filler in T100 and how we added that. And then I actually want to point out line item 3 in the data sheet here. A few years ago, we had a recommendation to add this test property, and that is the mass of the dry specimen prior to performing the bulk testing. And I know we got some feedback like from participants, what the heck are you doing? Why are you adding that? Who cares about that dry mass? That dry mass is actually a direct result of how well your laboratory prepared the specimen and scraped your mixing bowl out. And, I've got some data here. I wanted to take a look at this for a little while. And now that we've got some information from a few years, we can definitely see a trend with laboratories and how well they scrape and how well they mix and how it relates to their resulting data. It's pretty interesting. I actually pulled data from about 7 participants from this round who were all greater than 3 standard deviations away on both samples 55 and 56 for that bulk puck. And I'm not really surprised here, but every single one of them had some other test property that had a low rating as it related to the bulks, the heights of compaction at 8 and 100 gyrations, and the percent of maximum gravity after 8 and 100 gyrations. So it's pretty interesting to see. I mean, I'm not really super surprised by it. It's one thing that, as a laboratory, if you're testing and mixing and should be looking at those values, what's the final batch mass and how much do my pucks weigh? Am I getting everything I need to out of that mixing bowl? Actually, really interesting, too, to look at the data and see some laboratories who have way more material in their pucks than what was in the mix design.
Do you have any tips for how to do that? Maybe Ryan has some tips of how to properly scrape the bowl so you don't have not enough, but then also I'm very confused by what you just said, that they have more material than what was before. So I'm confused by that, but I'm just looking for tips for laboratories, not for me personally, because I will never do this test.
The main thing is that you want to, obviously, heat is key for everything. If you start getting too cold, you run the risk of the material sticking to your bowl and not getting it out of there. You want to make sure that you're consistent across the board. Whatever you're doing, make sure you're doing the same thing over and over. Because, it's not going to be clean to down to silver, whatever color your mixing bowl is. But, if you're looking for that same sort of consistency, same sort of color, definitely make sure you're getting your fines out of the bottom. I know definitely some of our mixing bowls, the very center of the bowl likes to accumulate material. If you don't give that little scrape at the end there, you can lose that as well?
There's definitely a buildup issue. That's one thing that we see happen, and to kind of tear into that ignition and solvent samples, when we mix those by hand, we see a buildup over the course of time. So we stop halfway through, we clean the mixing bowls, rebutter them, and then continue on. So that's one thing that we definitely see, but it's really apparent. I mean, I got some data here where our batching for this round, the total mass of the mix design was 4,965 grams. And we've got some laboratories reporting close to 5,000 grams in their pucks. And, people think, well, how could you do that? I mean, obviously, the rice is a way to do it. Right? We have a butter batch and we ask laboratories to butter their bowls first. But if you're getting almost 50 grams extra in the mix, I don't think you're cleaning out your bowl enough prior to even doing the samples. These are proficiency tests. You want to try to do your best to make sure things are clean and buttoned up as well as they can before you start. So if you're not taking that kind of diligence and making sure that you're getting your mixes the way they need to and comparing that mass, you definitely want to take a look at it. It's going to reduce the amount of variability that you're seeing with the samples and your results.
Yeah, that's a tricky thing. If you're a laboratory that's just used to testing already mixed samples and all of a sudden you have to mix it yourself only once a year, you can get out of practice pretty easily. But I know when we make proficiency samples where we mix back in the warehouse area, we run into that situation. Of course, we're mixing a ton of samples at once, but the first couple, and actually I shouldn't say just the first couple, sometimes you get in a groove and then you'll mix a sample and you'll see something go wrong, like just the way the mixer is operating and the way that the aggregate is in the bowl. You'll have like a half-inch chunk fly out, and then you have to go get that, and hopefully it's not covered in dust or some, you're not incorporating other things into the mix, but luckily that would probably be not a whole lot anyway with one piece of aggregate getting out. But you do have to get that aggregate, especially a half-inch piece, back in there, because there's not a lot of half-inch material in the mix to begin with, and that could throw you off a little bit. So you have to be cognizant of those things, and try to get as representative a sample as you can out of what you're mixing. I mean, if you ever need tips before you work on that, that would be a good thing to reach out to us about. If you're not sure what to do, or if you say, I've never mixed before. If you're new, what do I even use for this? That would be a reasonable question to ask. So since I'm saying that, so why don't I pose that question to you, Ryan? If I'm a new laboratory and I've never mixed before, and I say, I don't know what to do with this material, what would you tell me?
I would ask if you had any experience in cooking. It's the same sort of process.
No.
Well,
only ramen noodles and Hot Pockets in the microwave.
All right, well, then we got a dual thread here. So basically, make sure before you start diving into it, make sure your prep is ready. Make sure you have your equipment. Make sure you have your hot plate. This is something I've run into as well, where I'm getting ready to mix up, got everything set out, and I realized that I'd never turned on the hot plate. I turned it off the end of the day, forgot to turn it on in the morning. So well, shoot, now I hit a speed bump. All my materials ready, but my equipment isn't ready. So make sure your materials are ready. Make sure your equipment's ready to go. Look at the whole process before you start diving in on step one. Make sure you have a place to put your material, things like that. So just kind of look at the whole process, holistically before you just start chopping away at it.
That might be why I'm not a good baker. Because I do not follow. If I'm following and taking your advice, that could be part of my problem. So thank you for that tip there, Ryan.
Yeah.
Yeah, you're not wrong. Follow that recipe. I mean, same thing. We also see some data on the opposite end for this weight where the sample size is around 4,900 grams. And it's kind of like, okay, well, you're 65 grams light. More than likely, none of your heights are going to be even remotely close because you don't even have enough material in the mold. So you also got to be careful on that end too. Just make sure you're following the batching the right way and following that recipe.
Yeah, so whenever we have new trainees in the lab, same thing as baking. They're like, well, how do I mix it? Well, have you ever made cookies? Ever made pasta before? Same thing. You add your wet stuff to your dry stuff. Just follow your recipe, follow your proportions.
And for clarification, when you say butter, you're not actually meaning butter, right? That's kind of like a crumb coat. If we're going with the analogy,
Yes.
You're kind of crumb coating the inside of your bowl, and it's not actual butter. That's just a term that is used.
I know you're not as technically savvy as the rest of us, but did you really just ask that question?
I wanted to clarify.
No, for using release agent, we've had to tell people don't use the butter flavored cooking spray.
Really?
Yeah.
Okay.
Kim, you do technically, you will find buttered flavored cooking spray in laboratories.
Yeah.
Customarily, you will find that they have been spraying stuff with that. And it never occurred to me that someone might have taken the buttering term
Literally,
and
yes.
purchased that because of that. But I wonder now if that's what happened.
I'm just here to ask the questions that you think are so silly that who would think that? I'm here to ask those questions, John. So there you go.
I'm just going with it.
I feel like we've had a real breakthrough today. We've learned so much.
Thanks for listening to AASHTO Resource Q&A. If you'd like to be a guest or just submit a question, send us an email at podcast@ashtoresource.org or call Brian at 240-436-4820. For other news and related content, check out AASHTO Resource's social media accounts or go to ashtoresource.org.